Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 2 Differentiation Long Question Example 6. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Halima is given a piece of wire to construct an enclosed region as shown in the diagram. A, B, C and F, E, D are the arcs of two semicircles, both of radius x centimeter. So as you can see here, this is the arc ABC and the arc FED of the two semicircles consists of the radius x centimeter. Continue to read the question. The area of the enclosed region A, B, C, D, E, F is 1000 centimeters square. So this is the enclosed region, guys. Okay, which is 1000 centimeters square. Okay, according to the question given. Continue to read the question part A. Show that the length of the wire needed P centimeter is given by P is equals to 2 pi x plus 1000 over x. For the question part B, taking pi is equals to 3.142, calculate the value of x that makes P a minimum and show that the value of P is a minimum. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve this question. Let us begin our discussion for the question part A. Okay, for the question part A, they ask us to form this equation P is equal to 2 pi x plus 1000 over x, which in this case P is actually representing the perimeter of the enclosed region A, B, C, D, E and F. Okay, so from here let us continue. So in order to form this equation, the first step what we need to do is try to look for the information that can be used to convert into the equation form. Okay, in this case, take a look at the last sentence over here. The area of the enclosed region A, B, C, D, E and F is 1000 centimeters square. So this sentence is a very useful information which we can convert this information into a equation form. Okay, so from here, area of the enclosed region A, B, C, D, E, F is given as 1000 centimeter square. Okay, so from here we need to convert this into the equation form. So how are we going to do that? So please follow up with me, guys. Okay, from here we know that ABC and FED are the arcs of two semicircles, both of radius x centimeter. Okay, that means that for the semicircle ABC and FED, you have the same radius, which is x centimeter. Okay, so from here what you can do is, in order to calculate this enclosed region, so the first thing you need to do is you need to identify the diameter of the semicircle. Okay, in this case the diameter of the semicircle will be 2x centimeter. Okay, then you can ask me, so why we need to calculate the diameter? Okay, please hold on, I will get back to you soon. So from here, in order to calculate this enclosed region, what you need to do is, so assume that this semicircle you cut and then you paste over here. So when you cut this portion A, B, C and when you paste it over here, it will resemblance like a rectangle, guys. Okay, so when you cut this and paste it over here, okay, this one you ignore it for now. Okay, let me shade this and then you paste it over here. So it's actually resembling a rectangle area. So from here, in order to calculate this area, so from here you need the length of the, you need the width of the rectangle, okay, which in this case is 2x centimeter. So this is the reason why I'm asking you to find the diameter of the semicircle. So I hope you understand the concept. Okay, this one is already given by the question. But how about the length of the rectangle? It's not given by the question, so how we need to proceed? So in this case, no problem, you can write any variable you want. Okay, in this case, you just write here a variable y. Okay, I write here variable y. You can write any variable that you want. Okay, depends on your preference. Okay, so from here, to calculate this total area, you can use this form, guys, where you cut this semicircle and then you paste it over here, and it will look like a rectangle form, and then you can immediately calculate this rectangular area. So from here, 2x, which is the width, and then you times with the length y, you get equals to 1000. So from here, 2xy will be equals to 1000, and then from here you get your xy will be equals to 500. So this is your first equation, guys. Okay, so I hope you understand the information I'm trying to convey to you. So this is the first information that we gather. So the next step, what we can do is we can proceed to find the perimeter. So in this case, okay, let me erase this diagram. Okay, so back to the original one. So in this case, to find the perimeter, you calculate the length of AF, okay, which we indicate y over here, and then you calculate the arc of the ABC, and then you calculate the length of the CD, which in this case also y, okay, since the length are the same. Okay, and then you calculate the length of the arc DEF. Okay, when you calculate everything, you can easily relate with this equation. Okay, so let us proceed to the second step, where we can calculate the perimeter. So perimeter, so to calculate the perimeter, what you need to do, okay, please hold on, guys. So the perimeter will be equals to AF, you plus with length of the arc ABC, so length of the arc ABC, and then you plus with the length of CD, okay, and then you plus with the length of the arc DEF. Okay, so from here let us continue. So perimeter is equals to, so from here AF, okay, we can write the variable y over here, okay, and then you plus with ABC. Okay, so to calculate the length of the arc ABC, what we need to do, okay, you need to calculate them. So usually when you calculate one complete circle, arc of a complete circle is 2 pi r, okay, but then you're calculating for a semicircle, so from here it will be pi r. Okay, pi r. So in this case, your radius is x centimeter, so you just write here pi x. Okay, so the arc of the ABC will be pi x. Okay, length of the CD will be y. Okay, and then length of the arc DEF is also the same, which is pi x. Okay, so from here when you calculate, you should get your perimeter is equals to 2 pi x plus with 2y. Okay, so for the next step, what we're going to do is we're going to eliminate this y variable. So how are you going to eliminate this y variable? Okay, so before proceed to the elimination of the y variable, okay, let me label this equation as the second equation. Okay, and then I address this as a P, okay, not perimeter, guys, so please wait. Okay, P, P, and P. Okay. Excuse me. So what you're going to do is we're going to eliminate the variable y. So we're going to use the equation 1 to form a new equation. So from equation 1, so from here, since we are going to eliminate y variable, so from here y will be equals to 500 over x. So this will be your third equation. Okay, so let me label this as equation 3. So for the next step, what we're going to do is we're going to substitute this equation 3 into equation number 2. Okay, now I hope you get the concept behind this. So from here, substitute three into 2. So from here, your perimeter is equals to 2 pi x plus with 2 in a bracket 500 over x. Copy and then you paste over here. So from here, when you calculate this, you should get your p equals to 2 pi x plus 1000 over x. Okay, did you get the same answer? Okay, that means that your answer is correct, guys. Okay, you have successfully solved the question part A. Let me underline the solution. Okay, so that is all for the step-by-step working and solution for the question part A. Okay, let me proceed to the question part B now. Let us continue our discussion for the question part B, where we need to calculate the value of x that makes p a minimum and show that the value of p is a minimum. Okay, so in this question part B itself, we are required to find two informations. So let me label this. So this is the first one and this is the second one. Let us begin to find the first one. Okay, in order to calculate the value of x that makes p a minimum, what we're going to do is we're going to differentiate p with respect to x, and then we're going to set dp over dx is equals to 0. Okay, why dp over dx equals to 0? So we're going to relate this with the turning point concept, guys. Okay, so turning point concept is a situation where your differentiation will be equals to 0. Okay, why equals to 0? When your point is turning, it is a possibility that it can form a minimum point or maximum point. Okay, in this question we are trying to prove that the p is a minimum, guys. Okay, so let us continue. Okay, let me copy paste this equation of p over here. So since I've mentioned that we're going to differentiate this with respect to x, okay, so this x we're going to bring it to the top. So from here you get your p is equals to 2 pi x plus 1000 x to the power of negative 1. So from here we differentiate p with respect to x. So from here dp over dx will be equals to, okay, so you differentiate p with respect to x, so this one you only left with 2 pi. Okay, and for this, okay, you start to perform the differentiation. So from here you get negative 1000 x to the power of negative 2. Okay, so from here you get your dp over dx is equals to 2 pi minus 1000 over x squared. Okay, let me underline the fraction. Okay, since in the question they ask us to use the pi value as 3.142, so we're going to use that later on. But then for the next step, what we're going to do is we're going to set our dp dx is equals to 0. Okay, so from here, since your dp over dx will be equals to 0. Okay, why equals to 0? Because we are calculating the turning point. Okay, remember guys, the turning point concept, to identify whether the x value gives a minimum or maximum. Okay, so from here you set your dp over dx is equal to 0. So from here 2 pi minus with 1000 over x square is equals to 0. Okay, we're going to use the pi value as 3.142. okay, and then we're going to rearrange this equation. From here 2 pi will be equals to 1000 over x square. Okay, so let me underline the fraction. So from here let us substitute the pi value as 3.142. so 2 times with 3.142 will be equals to 1000 over x square. Okay, so let me underline the fraction. So since we are wanted to calculate the value of x, okay, let me swap the value over here. So from here your x square will be equals to 1000 over 6.284. so how you get 6.284? so 2 you times with 3.142, so that's how you get 6.284, guys. Okay, let me underline this fraction. Okay, so to get the x, what you do, so this value you square root the whole thing. Okay, let me copy paste this. Okay, so I copy paste this. Okay, and just I add the square root symbol over here. Okay, so from here you should get your x value is equals to, let me calculate this. Okay, 1000 you divide with 6.284. okay, and then you square root it. You should get your x value is equals to 12.615. okay, so this is the value of x, guys. Okay, let me underline this. Okay, so we have already find the first information where we need to calculate the value of x, okay, which might lead us to get the minimum point or maximum point, which in this case is the turning point, guys. Okay, but then we are not done yet. We still need to show that the value of p is a minimum. Okay, so how to double confirm that the value of p is a minimum? So we're going to perform the double differentiation over here. Okay, so from here, so what I'm going to do is, so let me copy paste this. You know what, I'll copy paste this, so it will be easier for us to perform the double differentiation. Okay, basically it's still the same. Okay, so from here let us proceed to perform the double differentiation. So in this case will be d square p over dx square. Okay, so you underline the fraction. Okay, you perform the double differentiation. Okay, 2 pi, since 2 pi is a constant, so you leave it as 0. Okay, and then you only left with this variable. So this variable you perform the differentiation. I mean -2 you times with -1000. So from here you get 2000 x to the power of -3. So from here you get your d square p over dx square is equals to 2000 over x cubed. Okay, so let me underline the fraction. So from here, when x is equals to 12.615, so you substitute this value into the double differentiation equation. So from here d square p over dx square is equals to 2000 over 12.615 cube. Okay, let me underline the fractions, guys. So you calculate this. Let me copy paste this. Let me calculate this. So 2000 you divide with 12.615 cube. You should get your answer approximately 0.9962. Okay, so in this case you get a positive value. Okay, when you get a positive value, it is indicating that the x value gives us a minimum point. Okay, let's say you calculate this and then you end up getting a negative value, then it will be a maximum point. Okay, so let me underline this. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.